Guys, and salam alaikum and Ramadan Mubarak. So I hope you guys enjoyed the last two parts, and in this part I'll be going through a couple more questions, basically number 13 all the way up to 17. And I hope to get part 4 out by tonight or tomorrow, so look forward to that too. And guys, if you guys could, it'd be really helpful if you guys can like the videos if you've enjoyed them and share with your friends. That way, if you like the videos, then YouTube's algorithm will try and put them on the top of the search bar. So that way you guys can easily find me, and it will help me a lot out as well, and I'd really appreciate it. So thank you guys. But other than that, let's begin the question, and I shall see you guys in a moment. Ciao. So, the diagram shows a solid cube. Now this cube is placed on a table so that the whole of one face of the cube is in contact with the table. Okay? The cube itself exerts a force of 56 newtons on the table, so that's the downward force going down. So you don't really need to know this specific, but this is the downward force. The pressure on the table due to the cube is 0.40 newtons per centimeter squared. So here they gave us a formula of pressure, which is force over area, and they want us to work out the volume of the cube. So first things first, we know that the pressure itself is 0.14. The force is 56, so that's these two covered. So we can kind of work out the area, and well, the area is basically base times height. In other words, W times W, which is W squared. So I can write that down here. And the volume itself is just base times height times the width. So W times W times W, which is W cubed. Now, essentially, we just need to find what W is. So using the pressure formula and just substituting the values in, we're going to have 0.14 on the left equals a force of 56 over an area of W squared. Now, to solve this one, just rearrange and make W squared a subject. All I would do is times W squared across and divide 0.14. So you get W squared equals 56 by 0.14. Now, put this in a calculator and then square root the answer. You should get a W value of 20. And therefore, to get the volume, just cube this result. So the volume is W cubed, which is 20 cubed, and that is 8,000 centimeters cubed. And that's it, guys. That's 13 done. Okay, question 14. So the diagram shows a parallelogram EFGH. All right. Now we got a couple lengths and an angle which is already defined. A, work out the area of this shape. Okay, cool. So to work on area of parallelogram, it's a bit tricky. So what I personally recommend is always try and break down shapes like these into triangles, yeah? So my advice is to start at E and just slice it across till you get to G. And then you'll realize that you're going to get two equally sized triangles. Okay, and then when you have two equally sized triangles, you can literally just find the area of this triangle and then double it to get the area of the parallelogram. So two triangles, add them up, and you got it. Now, to find the area of a triangle, it's just one straight up formula, and I think they give this to you as well. It's basically half AB sine C. And well, to use this formula, you always need an angle between two lengths. And well, we got it. So A and B are your lengths and C is your angle. So this means that the answer is now half times 9.3. And then you got, what is it, 14.7 and then sine 106. So put this in your calculator and then double your answer because you want to find both of these, yeah? So basically all of this times 2. And doing that, you should get an answer of approximately 131 centimeters squared. And that's it. So going to B now, it says work out the length of the diagonal EG on the parallelogram. So EG is the one we just found. So let's just call this X, yeah? Give your answer correct to 3 sig figs. So same things applies, yeah? When you got 3 lengths and an angle, always use the cosine rule, yeah? So the cosine rule itself, I believe, is given in the formula sheet. If not, the general formula is like this. It's always A squared equals B squared plus C squared minus 2BC cos A. Now the most important element here is the angle, yeah, A. And this is represented by this A here. And this means that the little a, which is its opposite, is this length. So that means X is little a and capital A is 106, which means B and C are the rest, 9.3 and 14.7. So all you need to do now is just sub everything back in, guys. So we should have X squared equals 9.3 squared plus 14.7 squared minus 2bc times cos 106. Yeah, so all of this is connected, yeah? And then when you put all of this in, remember, you're going to get a result for x squared. So then you'll need to square root answer. So x equals square root of whatever that answer was. And you should get a length of about 19.4 centimeters. Yeah, and that's it. 14 is done. All right, number 15. So the diagram shows a cuboid of volume V, and it looks like we got lengths given in terms of x's, okay? So this looks like a purely algebraic question. Now, A tells us to show that the volume can be represented by this cubic equation. Oof. All right, so it looks like it's going to take a while. Now, what it's trying to tell us is that, firstly, let's find the expression for volume. Well, we can know that the volume is just the product of these three lengths here. So let's go ahead and multiply all three terms, yeah? So we're going to have 2x plus 5 times x plus 1 times 3 minus x. Now, there's a number of ways you could do this. And my personal way is to always focus on the last two brackets, expand it, then deal with the first. So let's go ahead and expand these two, yeah? So we're going to go ahead and leave 2x plus 5 alone. So to expand this side, let's multiply it term by term, yeah? So we can say x times 3, x times minus x, 1 times 3, and 1 times minus x, okay? So when we do that, we're going to have a 3x, x times x is minus x squared, plus 3, and then 1 times minus x is minus x. And then go ahead and simplify this, yeah? So we're going to now have 2x plus 5 multiplied by all of this, but tidying this up first and do it in terms of power order, guys, yeah? So always start with the x squared. So we're going to have minus x squared first, 3x, take away x is plus 2x, and we got plus 3. Okay, so step 2 now. Now what you're going to do here is that you're going to now multiply this linear term with every single term in the second bracket. So what I'm trying to say is that we're trying to do 2x times that, 2x times 2x, and 2x times 3. And then after that, we'll do 5 times this, 5 times that, and 5 times that one. So there's 6 things to multiply. And when you multiply it, we're going to lay it out in power order, yeah? So check it out. So you got 2x times minus x squared. That's going to give us minus 2x cubed. 2x times that is plus 4x squared. Then we're going to get plus 6x. So keep in mind of the power orders, yeah? Next, we're going to move on to the 5 now. So 5 times minus x squared would be minus 5x squared. So just line it up. 5 times that is plus 10x. And 5 times 3 is plus 15. Now finally, all you want to do is just put a line and then collect the terms. So in order, you got minus 2x cubed. That goes first. 4x squared minus 5x squared is minus 1x squared. 6x and 10x is 16x and plus 15. And then checking with our result, is it the same? Yes, it is. Except they did it backwards. It shouldn't be a problem, but just for the sake of it, just also write it like that, yeah? So I would say volume equals this, and then copy this out in that order, and you're done. Okay, so looking at part B, it tells us now that there is a value of x for which the volume of the cuboid is a maximum. Okay, so this is talking about differentiation. Let's have a look and I'll try to explain along the way. So what we want to do is differentiate this equation. So I'm going to continue from here, yeah? So let's say now we want to find dv over dx. So differentiate volume with respect to x. To differentiate, guys, all you got to do is drop the power down. So it'll be 3 times minus 2, which is minus 6. And subtract the power by 1, so you get 2. Repeat the process, you get minus 2x to the power 1. If you just got x left, that vanishes, so you get plus 16. If you get a constant, there's no x, so that's 0. So this would be it. Okay, at this stage, now we need to find a certain value of x here. And in order to do it, we need to firstly equate this to 0. Why? Is because when you're finding maximums or minimums or turning points or stationary points, what they're talking about is that you have loads of curves like this, and a maximum would be the highest point on a certain curve, whereas the lowest point would be a minimum. These are also known as turning points, guys, yeah? But in this particular case, they want us to find this particular point, yeah? This coordinate, absolute highest value the y could be for certain x, okay? To do that, you can see that the gradient here is flat, so we got a flat gradient. This means dv over dx must be 0. So So when you see the word turning point, maximum, minimum, stationary point, differentiate and set it to 0. So let's do that, yeah? So let this equal 0. We're now going to have minus 6x squared minus 2x plus 16 equals 0. And then this is just your a straight up normal quadratic equation. So what I would do is I'll use a quadratic formula. So we can say, okay, let x equal minus b plus minus the square root of b squared minus 4ac over 2a. We're therefore going to have plus 2 plus minus the square root of b squared, which is 4, minus 4 times a, which is minus 6, times c, which was 16. Okay, and all of this over 2 times a, so 2 times minus 6. And when you plug this in, guys, you're going to get two values for x. Well, with a plus result, you're going to get surprisingly a minus answer of minus 1.808 dot dot dot. Or you're going to get an x value of, so let me write here, x equals. With a negative result, you're going to get plus 1.47. So now with these values of x, it's going to be only one of them, yeah, because you only got one solution. And well, my personal belief is that it has to be the positive result. Why? It's because you're dealing with a shape and you can only have lengths, real lengths. You can't have negative lengths. And that's it, guys. Okay, 16. So P equals 2A minus C over D. Now, what they have here is they have three terms and all of these have been rounded to a certain number of significant figures. Now, for this question, they want us to work out an upper bound for this value P, and we've got to show it working clearly. Now, to work out an upper bound for P or even a lower bound, we need to first figure out what are the bounds for A, C, and D. To do this, I always do it like this, guys, yeah? I always write A, C, and D, so always write your variables. Always do inequality signs like this, so less than equal, and also a less than on the right hand side. And then when you do this, you're going to go ahead and put your lower bound values on the left hand side and your upper bound on the right. Now, to get an upper bound for each of these values, you just got to think about what the next decimal point would have been for each one. So in this case, you're looking at the second decimal point, the first and the second. Well, the only way you can round a certain value down to this value if there was a 5 at the edge, at the end of it, yeah? So it would have to be 58.45. Likewise, for the next one, it would have to be 20.5. And the next one had to be 3.65. So that's pretty much your upper bound done. Now to get a lower bound values, again, it will be something similar, but you got to think about the value less than this one. So to round it up to 58.4, it would have to be 1 unit less than this value here, just before the 5. So it would be a 58.35. Okay. Next one would be, let's have a look. 19.5 and then 3.55. Okay, so that's the key idea. Now to work out the upper bound value for P, so P upper bound, we need to firstly think about what values we need to choose here. And by the way, guys, we can't just pop in any upper bound values for all of these terms because it won't give you the actual highest value. To get the highest, we need to pick the greatest difference between A and C and the greatest ratio between A and D, with the top and the bottom. To get the greatest difference, we need to have the biggest value for A and the smallest value for C. So it's going to be 2 times A, which is an upper bound, minus C, which is a lower bound, all over the greatest distance. So you want to have the greatest distance over from these two. So you need the lower bound for D. So you have to maximize the top and then minimize the bottom. So that way you're going to have a really big number. So when you guys do this, you're just going to replace AU with this value here. C, the lower value of C with this value here, and the lower value D with this value here. And then when you do that, so let's have a look. So we've got to show it. So it'll be 2 times 58.45 minus the lower bound of C, which is 19.5, over, where is it? Where's my mouse? Over 3.55. And when you guys do this, you should get an answer which rounds to approximately, so to 2 dp, guys, yeah, 27.44. And that's it. Okay, number 17. So guys, for this video, this is going to be the last part. Okay, so we've got 17a and 17b. Let's do this. Now for part A, they want us to show that the left hand side can be rewritten as the right hand side. Okay, doesn't look so bad. Show each stage where you're working. Now to do this, let's go ahead and write 2 of these brackets, because the squared bracket means there's 2 of them. So we've got 6 plus 2 root 12 times 6 plus 2 root 12. Okay, so now we want to go ahead and expand this, guys, yeah? So we're going to do 6 times 6, 6 times these lot, this times that, and 2 root 12 times 2 root 12. Now, 6 times 6 is 36. Now, when you times a whole number with a mixed surd and whole, always times 6 with the whole number 2. So it'll be 12 root 2. So we're going to get plus 12 root 2, 12 root 12, sorry, plus another 12 root 12. And then we've got this term times this term. Again, you times whole of whole, surd of surd. So you're going to get plus 4 root, well, 12 times 12 is 144. And the square root of 144 is, well, 12. So essentially, this is 4 times 12, which is 48. So plus 48. Now, next step. So breaking this down further, we're going to go ahead and collect like terms, guys, yeah? So we're going to do 36 plus 48. That's going to give us 84. 12 root 12 plus 12 root 12 is 24 lots of root 12s. So to collect like terms in terms of surds, guys, always think of these surds as x's, yeah? So it's like saying 12x plus 12x will give us 24x. Now we're almost done. What we need to do now is somehow factorize. And oh yeah, we need to break down root 12 to get root 3. Now thankfully you got a calculator, guys. So I will just put root 12 in. If you put root 12 in, you should get a result of 2 root 3. And well, 2 root 3 times 24 will give us 48 root 3. I mean, technically you could just write 24 root 12 and you get that as well. And again, put 84 here. And then lastly, if you factorize this carefully, I mean, we don't even need to think at this stage. You know you're going to pull out 12. So dividing this by 12, you should get exactly as it is there. So we get 12, and you're going to get 7 here, and you're going to get 4 root 3. And that's it. That's 3 marks bagged. And lastly, for part B, guys, simplify fully this entire algebraic fraction. Now, thankfully, this is not as bad as it looks, because again, you got a calculator, and there's a trick to this. Now, when you got all of this term to a power, what I would do is distribute the power to each term, yeah? So what I'm trying to say is that 27 will get a power of minus 2/3. A to the 12 will get a minus 2/3. Because they're on the same line, you just stick them on like that. So they're multiplying at the stage. And then t to the power 15 would also get it. Now, all of this is just calculator work. So 27 to the power of minus 2/3 is 1/9. Now for the next part, it's just going to be 12 times minus 2/3. That's going to give us minus 8 as a power. And for the t term, 15 times minus 2/3 is just minus 10. Okay, I mean, this looks like a legit answer, right? Now, I'm guessing they probably want you guys to simplify this answer fully. So probably don't leave a negative form, yeah? So what I would do is firstly, you got 1/9. 9 goes on the bottom. A to the negative 8, that flips underneath, so it becomes a to the positive 8. T to the negative 10 goes up, it becomes t to the plus 10. So yeah, so negative powers essentially means reciprocal, so bring it down, bring this back up, and the 1/9, bring it down. And that's it, guys. This should be your final answer. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications. And if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.